Okay, so we're going to talk about congruent triangles. Now, what does the word congruent mean from just earlier in this year where we said, oh, those sides are congruent? What were we really saying? Congruent means, if I say two sides are congruent, the same, yeah, it means those sides are the same. So let me shut the door. So congruent triangles essentially means they're the same triangle. Okay, so we have some ways that we can prove that triangles are congruent, but just like before, that word congruent means equal to. Okay, if something is congruent, it is equal to the other thing. So congruent triangles means one triangle that's equal to the other. And what we use that for, well, first we will prove that certain triangles are congruent within a diagram. But if triangles are congruent, then we also would know that all of their corresponding angles and sides are congruent. So if one triangle is congruent to the other, then all of the corresponding angles and sides are equal to each other as well. And this is something we use in our proofs later on, where we say CPCTC. CPCTC really just means that the corresponding parts, corresponding mean matching, so the matching parts of a congruent triangle would also be congruent, that all of the matching angles would be congruent and all of the matching sides are congruent. That's what this shorthand is talking about. And we use that, we do what are called CPCTC proofs, directly related to that kind of statement that we're talking about now. So the biggest thing with congruent triangles for today, right now, is that order matters in our statements. Okay, so that's super important as we move through, that the order is going to matter. So if I'm given a congruency statement, so a congruency statement is saying this is congruent to that. So my statement is going to say that cat is congruent to triangle God. Now you may have looked at that and wanted to say cat and dog are congruent if you look at the triangles, CATDOG. But I know that CA and GO correspond because they're marked with the same number of tick marks. So I know that this side of that triangle that's marked with 3 tick marks has to match up to this side of the other triangle, which also has 3 tick marks, which means this triangle has basically been tipped over, and that's what I'm looking at over here. And so the diagrams can be a little bit tricky sometimes. Order matters. So CA corresponds to GO, or I could say CA is congruent to GO. AT right here corresponds to what side in my other triangle? DO. DO or OD, yeah. So 2 tick marks to 2 tick marks. So AT corresponds to OD. Last, CT corresponds to GD. Okay, so if I know, I should be writing congruent, I guess. If I know that my triangles are congruent, then I also know that all of these matching sides are congruent. And let me color code here. So we looked at CA to GO. Then we knew that AT, so even if I didn't have the diagrams, if I just had the statement, then I also know that AT goes to OD. And last, I know that CT, these outer letters are going to match with these outer letters, GD, and that's this segment here. Okay. So now that's our corresponding sides, but we also have angles that are congruent. So what would angle C be congruent to, given this statement? Angle C would be congruent to angle, which did you say?
G.
C goes to G, exactly. Angle C goes to angle G. I feel like this isn't zoomed in enough. Angle A would be congruent to angle, that one should be easy because just looking at it, A is the same as angle O, those are the right angles there. Angle A is congruent to angle O, and angle T is congruent to angle D, okay? So one piece that we're starting with in this unit is understanding how to write a congruency statement, which is that we have to order things the right way so that things match up, or given a statement, like the two down below, that we can write all the sides that match and all the angles that match, and it's all about ordering things correctly. So for the next two examples, it gives us another congruency statement with no visual. So I know I have these two triangles and that they're congruent, or they're the same, they're equal to each other. And if this is true, so I'll get us started here, then I know that JK, the side that goes from J to K, must be the same length or congruent to the side in the other triangle that goes from T to R. So JK must be congruent to TR. And really those are segments. What would be another set of congruent segments given that statement? Would be another set of congruent segments.
KL be congruent to RS.
Yeah, KL here to RS. KL would be congruent to RS. Chance we're in notes number 1 in unit 6. And then our last one are going to be our outer numbers. So connecting J and L, what would that be congruent to? T and S. TS here. And then we have angles. So those, given that these triangles are congruent, all of these sides are congruent. And we also know that angle J is congruent to angle, that angle K is congruent to angle R, and angle L is congruent to angle S. Yeah. So now you do the next one on your own, and I'll kind of quietly start writing it up here in a minute. Okay, see if you can write what are all the sides that would match, and there should be 6 total statements that you have to write. And what are all the angles that match? Okay, so someone give me a set of sides that would be congruent.
MO and TU.
Exactly, yep, MO congruent to TU. And what else?
ON, UE.
Congruent to UE. And last sides?
MN and TE.
MN and TE. And angles, angle M to angle,
T.
angle O to angle,
U.
angle N to angle
E.
E. Yep. Good. Now the next two are a little funny. Normally we do transformations at the beginning of the year, but we shifted it till the end. It's kind of a wait and see. Will we be remote? Will we not be? But we didn't want to do it at the beginning of the year this year. So transformations we haven't talked about yet, but I think we can do it anyway. What happened to ABC to get here? What happened?
It's like flip.
It's like a flip, yeah. Really, it's a reflection, okay? So it was a flip or a reflection over the y-axis. Okay, but what happened if I color code ABC, so this side, AB, it just flipped over and is now this side RS. And this side CB, again, flipped over is now ST. And then CA to RT. So what we want to do on these triangles is not list all the matching sides and angles. I just matched the sides with colors. We want to write the statement, meaning we want to write this. Now, there's some kind of like, there's several different ways that I could write this statement. So let me show you what I mean. I could say this, that triangle ABC is congruent to, so ABC goes down yellow through red. So I want to go same over here, down yellow over red. RST, triangle RST. So those would be congruent triangles because I've matched up the yellow and the red sides as I wrote it, and then the blue sides kind of in there by those outer letters, okay? But I have to match up. So I could have also written that triangle, just to give you another version of this, CAB, like I could have started here, CAB, that's still that triangle. What triangle CAB would be congruent to would be, I'd have to rearrange the letters over here. So the way I think about it, especially with colors up here, is I went up that blue segment and then I went down yellow. So I want to do the same over here, up blue, down yellow. So CAB would be congruent to what triangle?
TRS.
TRS. Okay, and then there'd even be another way that I could write that. I could have started at B. And really I could go BCA or BAC. Okay, so I'm not going to write them all, but as you can see, there's many ways that I could write a congruency statement. Both of those are correct. Okay, all that is important here, again, just like I wrote up above, is the order matters. Okay, so like when I grade these quizzes and tests for this unit, I always have to keep in mind that like what I wrote for a congruency statement may not match what you wrote, but that doesn't necessarily mean you're wrong. It's all about where did you start in the first triangle, does it match how you wrote the second triangle. So now I want you to look at, this one's a little bit trickier. This is a rotation. So what happened is ABC rotated and like from like down there, I like flipped it up here, was a rotation. And so, and I'll color code for you. So what happened is this segment flipped up, it's here. This segment flipped over, it's here. This slanted segment matches that slanted segment. So now, see if you can write a congruency statement that matches what we have here. Which really they're the same letters, so that's kind of a not exciting moment. Okay, but see if you can write down what triangle is congruent to what. So these triangles they're the same, they're ABC and RST. So if I went, let's see, ABC, it's still gonna go RST, right? Yeah. Did anyone have anything different than that?
I did RTS is congruent to ACB.
RTS is congruent to, so RTS to what?
ACB.
Yep, that works too. RTS is congruent to ACB. Good. So that's kind of piece one. The next thing that we can do is some algebra stuff. So if we're given that triangles are congruent, well then we know that CPCTC piece, right? That the corresponding angles and sides are congruent. So given that these triangles are congruent, meaning they're equal to each other, I can match up the lengths that are marked here. So like these, this side with X has 2 tick marks, match that to this side, which has 2 tick marks. So I know 7x subtract 4 must equal 31. Or 7x equals 35. Oops, sorry. And x equals 5. Same idea to solve for y. Well, 4y plus 8 corresponds to 24. Because they both have 3 tick marks. And then I can solve from there. So subtract 8. 4y equals 16. And y equals 4. That's the easy setup when it marks the matching sides. The next example doesn't mark which pieces correspond. But what it does give you, and so this is something you need to learn to like lean on these pieces. What it does give you is a congruency statement. So here it's showing you what mark, it doesn't have letters around the outside. It's saying these are the pieces that match up. It's still giving you the pieces that match up on this second example, but it's giving it through this statement. So if this is true, remember it has to match. So MA, which is here 23, MA would correspond to what side in my other triangle? NE. And AS would correspond to what side in my other triangle? ER. And last, MS here would correspond to this NR. Okay, or I could have marked it with tick marks as I went around. Like if you don't have colors, I could have said, well, MA to NE, AS to ER. Okay, and so on. So you could mark it, obviously you might not have colors at your desk, but you can mark it with tick marks going around so that now I have my sides matched up. And I can also match up my angles where I know like to solve for X, angle E, what must angle E correspond to? Angle E would be the same as A, yeah, because they're in the same spot in this statement. So in terms of this one, 16x must equal 112. E must correspond to A because of the way this statement is written. And then I can divide by 16. And 112 divided by 16 is 7. Okay, so there's X. Now that I have X, I can find Y. So this one I couldn't have started here, right? Because I have both an X and a Y. But now that I have X, I could plug that 7 in and rewrite this side as 21 plus 5Y. And this side 21 plus 5Y, what is it equal to? Plus 5y is equal to what on my,
2.
is equal to this
Oh.
length, 41. Because this side is congruent to this side.
Oh, yeah.
And then I subtract 21. and 5y equals 20, and y equals 4. Okay, so the way that this page in our notes is set up, the first example is like level 1, everything's pre-marked for us. This is like level 2. I'm given a statement, but nothing's pre-marked. I gotta make sure I match up the correct parts using that statement. The last one is like level 3. I'm not given a diagram, but I am given a statement. And so I know that KL and RS, so if I were given this on a test, I might be like, well, I don't know, what do I set these equal to? Well, I know from the statement that KL is congruent to RS. They're in the same spot in this statement. So if this triangle is congruent to this triangle, then this side is congruent to that side. So I can say that 4x equals 2x plus 12, or 2x equals 12 and x equals 6. It doesn't just ask us for x though, it says find x and KL. What must KL be? 4.
Oh, it's just.
It's gonna give me 24. And just substituting in that x value. Okay, so that's piece 1. And we're gonna be able to do a little bit of notes number 2 as well. Let me talk about real quick. Let me double check myself before I want you to get the homework out. We're gonna kind of take a break and practice this before we do anything new. And I will, those of you who are online, I'll share screen. Okay, I don't think the slide deck posts, something weird happened. Did you lose a slide deck in classroom? There was week 8. It was 9, I don't know, something was grayed out still, so it should be there now. But if you look at this week in classroom, so now we're almost done with week 9. Today I kind of just pushed everything over. So we are gonna get to notes number 2, I think. Now tomorrow, we were kind of encouraged to not run live classes tomorrow because the quarter is switching over. So some of you have some new classes starting, and just to kind of allow you to have some time to organize yourself around that. So tomorrow we won't be meeting over Zoom. So I want you to all hear me right now, but you will be completing a warm-up. There'll be a key that I'll post on Classroom so you can check it. And then you're going to complete, we're gonna do the evens right now on this. You're gonna complete the odds on this homework, and you submitting this tomorrow is your attendance. So if you don't submit the homework to me, you get marked absent for class tomorrow. That's how I'm taking attendance. So you have got to finish this up, scan it in, get it into me by 3 p.m. tomorrow. Yeah.
Can I turn that, if I do that tonight, can I turn it in tonight?
Totally.
And can I go to the bathroom?
Sure. Yeah. Yeah, you could do it tonight and turn it in, and then you can just focus on whatever else you need to focus on tomorrow. Okay. So what we're going to do right now is go through the evens of this, just to kind of look at how things will look when we get to doing, quizzes, tests, whatever, with these congruent parts. I'm going to give you some time. Let me stop sharing. To look at the evens, try to just do evens, and don't be tempted to do all of them to get homework done, because then you can just get further if you look at just the evens. Okay, so start looking at the evens here. It's a little bit of a weird setup because 1, 2 is this way, and then it goes this way. So just be careful. This is 2. It's marking what matches you want to write the statement. Okay, then 4 is here. Then 6, 8 down here, then it goes back up here, I think. Yeah, it's only 9 down below. Okay, so I'm gonna give you some time right now to try this stuff out on your own. Then we'll go over it and you can check your work. And we will start, let me look at how much of unit 2 or notes 2 I have in here. It would be good if we could do all of notes too, because then we'll do some proofs before you go remote the second half of the week. Just gonna see. It's week 9. I am really hungry. I think I'm eating Mrs. Gilbert's banana. I'm just gonna do it.
26 or 27?
Homework 26. Like I said before, there's all different ways that I could write it. So let's pretend. And so what you need to look for in terms of yours being correct is whatever way I write my letters, the same, like whatever X goes to on mine, your X should go to the same letter. So even if it's out of order, the kind of individual letters should match where they're placed. So if I go, let's see, I'll go triangle XWY is congruent to, and so the way that I'm looking at this, XWY, that's kind of the path I took where I went from 2 tick marks, 1 tick mark. And also I went from this 3 arched angle, which would match here. So I'd be going here to here over on this triangle. So XWY would go correspond to BCA. And so your statement may look different than mine, but as long as wherever X is, B is in the same place over here. Wherever W is, C is in the same place. And wherever Y is, A is in the same place. So you can kind of check yourself in terms of, do those these angles match? As long as your angles match the same as mine, your congruency statement's good. Okay. Does anyone want to question one of theirs or they're unsure if they have it? So then 4, skipping 3, is just going the other way. Now this is the first time we've seen not a triangle. So congruent figures is not, we're not just talking about triangles, we're kind of focusing on triangles the further we get in this unit in particular. But we could also have, these are quadrilaterals, 1, 2, 3, 4 sides, and they're congruent. The angles are marked, but it also gives me a statement. And this statement works the same way where I know, okay, so GH must go to Q, is it QQR? Okay, so I can write GH is congruent to QR. Oh, so Evan, I lied to you about 6 total, because if it's more than a triangle, like this one, I'm gonna have 8 total things. And then here, H to J corresponds to RS, which is here. Okay, and so it's like funky because it got flipped around. So use this to help you match up the pieces. Congruent to RS, and then JK, which is here, goes to ST, which is here. JK congruent to ST. And then last, I have this GK, which are really the outer letters here, are going to go to QT. Going to go to this small side over here. Okay, so I have 4 pairs of congruent sides, and then I'm gonna have 4 angles, which is a lot easier. I'm just gonna go down the line. So angle G is congruent to angle Q, barely have space. Angle H is congruent to angle R. Angle J with angle S. And angle K with angle T. And I'm just going down the line, G to Q, H to R, J to S, K to T. Or I could have used the marks, this single to that single arc, this double to that double arc, triple arc to triple arc, 4 arcs to 4 arcs. Okay. For this set 5 through 8, we're using our statement. So angle M, which is here, would correspond to what angle in the other triangle? X. And then measure of angle X. And so we could also say that angle M then must equal what? Angle X is 33. So then this must be 33 degrees. The measure of angle M must also be 33 degrees. Remember, congruent means equal to. So when we're saying all these parts match, that means they're the same measurement. So angle M is equal to angle X, they're both 33 degrees. On 8, XY, what would XY be congruent to in the statement? XY would correspond to MN. And what does MN equal? 8. Okay, so I can also fill in values here, not just what piece are they equal to, but then what does that mean that their value is? Okay, if MN is 8, then XY is 8 because they're congruent parts. Same with the odd ones that you'll do between today and tomorrow. 9 is a tricky one. We match up the parts to get our equations, how to solve for Y and X. We need to match up which angle goes to which. 10 is similar, so let's look at 10 together. So on 10, let's see, where is even the, that's weird, is that an M? There, and an M here. Okay, well, let's start with X and Y. I don't see another Y though. Huh. Okay, well, let's see what happens here. Maybe I may have cut it funny. Maybe I'm missing a piece. So angle U, which is where X is, would correspond to what angle in my other triangle?
N.
Angle U would go to angle N. And so I know that by matching up the parts. Now, do I know what angle N is? No, right? It doesn't tell me what angle N is. But it does tell me that this angle is 142 and this angle is 24. Could I find angle N?
Yeah.
Yeah, because this is a triangle. And so just like always, triangle has to total 180. So I have 142 and 24 gives me 166. So this angle here is going to be 180 subtract 166, or how many degrees would angle N be? 14. So it'd be 14 degrees, which means this angle would be 14 degrees because they're corresponding angles. So then 2x subtract 50 would equal 14. Adding 50, 2x equals 64. And x equals 32. Oh, you know what it is? I'm so silly. M isn't a variable. It's saying meters. That's why there's an extra variable there. This is saying this is 13 meters. It must have had like units selected on the options. So now that I know what X is, I can solve for Y because this side NP, well, it better match SU because that's the only side we have. Let's double check. NP goes to US or SU. So I know that this length corresponds to this length, or that 2x subtract y equals 13. Because I already have solved for X, I can plug that in. 2x subtract y equals 13, or 64 subtract y equals 13. Gonna run out of space. So then negative y is going to equal negative 51. And y equals 51. And you'll see that a lot where like you have to find one variable first, then you're able to find the other variable because you can plug that in. Okay, 12. Trying to think if we've done enough to do 12. On 12, what it's looking for is this is a shape we just left. This is our parallelogram. So I know that my alternate interior angles are congruent. So that would mean that all three of these angles would be the same. Okay. Because this angle would match this one, this angle would match that one. And then they're sharing this length. So they both have this length in the middle. So we can see all sides are the same, all angles are the same. So this shape, this triangle is congruent to this triangle, okay, and that's the explain your reasoning. And I could write a statement, so that means that triangle WXY is congruent to triangle WX. What does WX correspond with sidewise? WX would go to
YZ.
YZ. Yep, so it would be congruent to YZW. ZW. Making sure I started. So another thing I checked is that in this triangle, I have those double arcs. So I got to start at the same part. W goes to Y. It's another way you could look at it. X goes to Z. This Y in this triangle goes to W in the bottom triangle. Okay, but that's Y. It's a parallelogram, so we have alternate angles. Might as well do 14 since I've done the rest of the evens video. This is just matching up parts here. Now it marks my angles. So angle A goes to angle S, or this angle would also be 45. Angle B goes to angle Q, or this angle would also be 80. So to find angle 1, I got to use the fact that the triangle totals 180. So let's see, 45 and 80, so that's 125 degrees between these two angles. How many degrees must angle 1 be then? 55. Yep. Okay, so that finishes like half of that work. And again, the other half, I want you to submit tomorrow for your attendance.
That's minute now.
Maybe after class. Don't pull it out right now because we're going to do some notes. So then I am going to kind of power through notes 2 for a couple reasons. First of all, you're here and we're going to be doing more of notes 2 on Thursday when you're not here. But I'd much rather talk about these proofs and this congruent triangle stuff while I have you in the building. What you're going to find, Chance, what do you need? Yeah, is that on Thursday, we are going to do a quiz review. Now, the quiz for this unit, I'm calling a checkout quiz, meaning I'm going to put it in as 100 points, but I'm going to put it in under like the formative category or the one that weighs a little bit less, just so that, and it's going to be like an assignment released to you that you submit. Like it won't be a quiz in class. I don't think I have it. Maybe we'll do it in class, but either way, it's not. It's more of a worksheet that's graded. Can't remember if I put it in here or not. Versus a formal assessment to give you some practice with the beginning proofs here. Looking to see if it's in here. I don't know if it is. So notes 2, we were supposed to kind of do this in 2 different days, but I think it's okay to just keep going. It all relates. And what we're doing on notes 2 is we're starting to learn, like, we're not always going to be told that triangles are congruent. So what do we need to be told in order to determine that they absolutely then must be congruent? What we don't need is we don't actually need all of the parts to know that that's the same triangle. There's a few different ways that work. And if it was a traditional year, I'd give you like little straws and you could move them around and see why it has to be the same triangle if these 3 pieces are true. So one thing here is that we always need 3 pieces to prove that triangles are congruent. Okay, so you need 3 pieces of information. Okay, having just 2 pieces is not enough. We need 3 pieces of information. So what this is saying, what I just said, it kind of repeats here. Without verifying that all of the parts are congruent, we can prove 2 triangles are congruent in the following ways. So one way is SSS, or side, side, side. Okay, if the 2 triangles, if all of the sides in the 2 triangles are the same length, there's only going to be one way to put those 3 sides together, then my triangles must be congruent. So what I would be given is possibly, okay, HE is congruent to MA, EY is congruent to AN, and HY congruent to NM. So if I knew that that was true, One of the best things you can do for yourself this unit is mark things as you go. So HE to MA. EY, which is here, to AN. HY to NM. There are my corresponding sides. If I know that all three sides are congruent, then I know my triangles are congruent. So triangle HEY would be congruent to what triangle? HEY, MAN. Exactly. So that's way number one. By the end of this unit, we'll have 6 different ways that we can prove. We're starting with 3. The second way that I can prove that my triangles are congruent is side angle side, or SAS. Now here's the important piece with side angle side. Where'd my red pen go? This is super important. When I say SAS, just like my congruency statement, order matters, the way that I'm writing this, order matters. Meaning it has to go a side, then the angle between it, and then the other side. So the angle literally has to be between the 2 sides that I know that are congruent. So I'm going to give us an example. If I knew that HE is congruent to MA, EY is congruent to AN, I'm going to stop before I give the third piece of info. And I'm going to mark it. HE to MA, EY to AN. So if I knew those 2 pieces, if the third piece is going to be an angle, the only way it would lead me to say the triangles are congruent if it's the angle in between those 2 sides. Which angle is in between the 2 sides that I have in my triangle? A, yes, on this one. Angle A is between those 2 sides. So angle A would have to, I'd have to know that angle A is congruent to which angle? If I'm given this angle, that's angle side side. It's not the same. So when I'm listing these things, it's in one triangle. So I'm comparing the 2 and I'm saying this side matches this side, this angle matches this angle, this side matches this side. But in terms of deciding which case I have, I'm just looking at one triangle and seeing the order of what I have. So the order of what I have, whether I start here or start there, is side angle side. What I can't do to figure out the order is I can't like start in the middle and then skip. See how there's like a section over here I'd have to skip to write it out. So I always have to start at like one end of the 3 things I have and work around to figure out what I have. So this is side, angle, side. I can't skip a side and an angle in between to write out which case I have, okay? They're always going to be lumped together like that. So like here I have a side followed by another side by another side. I didn't have to skip any sides in between. I can't skip around and go like angle side, skip side. That doesn't work, okay? So if this is true, then again, triangle, hey, is congruent to triangle man. Okay, because I have an angle, side, angle. I'm sorry, side, angle, side. My brain was here. Side, angle, side. Same idea, I could have it the other way around, right? Have an angle and another angle, and then the side, and again, the super important piece is that the side is in between the 2 angles that I'm given. So if I'm given, for example, let's say angle A congruent to angle M, and angle Y congruent to angle N. So first I'll mark that angle H to angle M, angle Y to angle N. I need a third piece of info. There's only one piece that's going to give me angle, side, angle. What side is between those 2 angles? What side length is between the two angles or connects the two angles?
E, or I don't know how to say it.
Well, you're gonna have two letters to say the side. So here's
Oh.
an angle, here's an angle.
HE.
HE is here. That doesn't connect them. Because see that angle's hanging out over there.
HY.
HY connects them, yeah. So it's gonna be the one between, so it's gonna live between these two angles. So if I also knew that HY was congruent to MN, then by angle side angle, I would know triangle HEY is congruent to triangle MAN. Okay? So obviously this is moving towards proofs where we want to be able to find these pieces, and if we have these three pieces, whether it's side, 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 side angle, side, or angle, side, angle, then we can prove the triangles are congruent. We cannot use side, side, angle. I'm going to write it out because it's kind of a bad word. Okay, so to say triangles are congruent, we can use side, 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 side angle, side, or angle, side, angle. These are the things we're looking for. Those three. We cannot use side, side, angle. Or if I wrote it the other way, angle, side, side, but I didn't want to. Okay, easiest thing to remember that you cannot use. If it's a swear word one direction, it's not usable. Okay, so no side, side, angle, or angle, side, side. Okay, this does not work. It doesn't prove that the triangles are congruent. Okay, so looking at these diagrams, we're going to decide, are the triangles congruent and how? So my first diagram, it tells me C is the midpoint of BE. What does that mean? It must be true. C is the midpoint of BE. What's true then? What's equal to what if that's true? C is in the middle of BE.
I mean, A, D is equal to B. A, B.
Well, not necessarily. I don't know that these are the same. But if C is in the middle of this segment, then I do know if it's in the middle, then it broke it into two equal amounts. That it'd be the same amount on both sides. If C is the midpoint, then it'd be the same amount on both sides, or this length BC would be equal to this length CE. So that's one thing that I can take from that. I'm going to write, because we're getting to proofs, if I were to use that, I could say, oh, this is equal to this then, by definition of midpoint. I also know that one of my angles, or that I have an angle pair that's congruent. Does anyone see something that's happening in this diagram that we've maybe seen before? Certain type of angles in the middle there. What are those called when it's crisscrossing like that? Right here. What's that called?
Interesting.
They're intersecting. What are these two angles called though? They are vertical angles. We know that vertical angles are congruent. So the way that the diagram is given to us, we know that this angle here and this angle here must be the same angle because they are vertical angles. Now, if I was writing a proof and I wasn't just looking at a diagram and deciding if they're congruent or not, if I was writing a proof, then I'd have to say, well, which angle is congruent to which angle? The issue we run into in this diagram is that this is angle C and that's angle C. They have the same kind of what I call basic angle label, okay, if I just use the center letter. So I want to instead say that ACB, that on this side, this angle C, ACB, so angle ACB is congruent to DCE. It's still C compared to C, but it's showing me that one of them's on this side, the other's over here. But this angle C is congruent to that angle C by vertical angles. Vertical angles are always congruent. So those are the things, given this diagram, that we can say. Midpoint, okay, those are the same vertical angles. Are these triangles congruent? Do I have one of my three cases? Side, 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 side angle, side, or angle, side angle? What do I have? Which one? Side, 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 side angle, side, or angle, side, angle? Yes. What do you think?
Angle, side angle.
How many angles do I have? I only know one. So, okay, let me clarify. When I'm deciding which case I have, remember, I'm only looking at one of the two triangles. So
Angle,
what do
side, side.
I have? Side,
Angle.
angle, side. I have a side that matches a side over here, an angle that matches an angle over here, and then another side. Okay, so when I decide which one it is, I'm no longer doubling up. I'm going, okay, so these are the pieces that I have matching, which would be side, angle, side. So I can say, and order matters here. So if I go A, B, C, I go A, B, C, that has to go to D, E, C. I have to go in the correct order. By side, angle, side. Okay, my triangles are congruent by side, angle, side. Now here comes a piece, I can't even remember what unit we used it in, but we have used this property before. This is the unit where it really comes to be super important to us. If you can see these we use it all the time. This is gonna happen all the time, this unit. These triangles are sharing this side. So would you agree with me that in this triangle here, DT in that triangle is the same length as DT in this triangle, right? It's the same length. If I look at this triangle, DT is whatever length it is. Over here, it's the same DT. So they share this side, which means blue triangle, that length is congruent to that length in the pink triangle. This is the reflexive property where we say something is equal to itself. We used it, I think it was unit 2, but in a little bit different way. This unit, we use it all the time. So in my proof, I would say reflexive property, that DT is congruent to itself, that's the same DT in pink triangle as it is in blue triangle. And if I knew that it's the same, now look, all of their sides match. So can I say that they're congruent by one of the statements up above? Which one do I have? I don't have any angles, so it can't be this one, or it can't be that one.
So sides.
I have all three sides. Yeah, so again, we break it down into one triangle to decide what I have. I have side, 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 and that triangle matching the other triangle. I have three sides matching. So triangle ADT, and again, order matters, but I'm trying to speed up a little bit. So ADT, EDT, or sorry, ADT goes to EDT, right? By side, side, side. Now our next one's quick and easy because it's all marked. I have three sides, so I could say that they're congruent by side, 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 just because side here, side there, side there. So again, looking at one triangle, I have side, side, side. I could also have used, so triangle cat congruent to triangle CAT to triangle God by side, 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 or I could have also used side, angle, side. They also have an angle between these two sides here. I could have also used side, angle, side. So there's kind of two ways that I could say that those triangles are congruent. On the last one, it doesn't give me any additional information, and it gives me an angle looking at one triangle, and then a side, and then I'm gonna write it really far away, another side, so it doesn't look like a swear word. Can I use that? No, and it doesn't give me any other information. If I look at one triangle, it goes side, side, angle, or angle, side, side, however I wanna look at it. No, okay, so I cannot say that they are congruent. Okay, so there's not enough info there. If I knew one of the other three, sure, but just given an angle aside and aside in that order, that's not enough. So that's kind of an intro into side, 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 side angle, side, and angle, side angle. What we didn't get to in notes 2, unfortunately, is doing at least one proof together. I mean, we could maybe squeeze it in here at the end, but should we? Let's do one. Well, we can do one. It's only a 4-star. So when we look at our proofs, because Thursday you will be doing this, I highly encourage you to Zoom, join me so that you can go through the rest of these together. Just like our other proofs, first we have our givens. So here, angle ATI congruent to angle RTI, that's given. Super important as you write these to mark it so that you can see which one of these do I have, which one do I have in the end. So ATI would be here, ATI, and RTI would be on the other side. So those angles I know are congruent. I'm also being given that TA is congruent to TR. That's given. TA, TR. Now here's a super important thing that we are always going to look for because it happens over and over again. I see it in proof number 2 as well. This is reflexive property. They are sharing a side. Anytime, when I'm given a proof, I'm not going to be given all 3 pieces I need. I need to look for things like vertical angles, reflexive, midpoint, to find the 3rd piece usually. At least the 3rd piece, if not the 2nd and 3rd piece. So I'm given this, the diagram gives me this. Because they share this side, I can say that TI is congruent to TI, that's reflexive. Again, we see it over and over again, that particular property. They share a side, that's my wording. Now I'm done. Now my last thing, I'm gonna cover up a triangle. I have side, angle, side. I have side, angle, side. That's the option I'm going to go with. So I can say that triangle ATI, and again, your statement might be written in a different order than mine, is congruent to triangle RTI. Oh, I guess I should have used what they had. That's okay. Triangle. So they had TRI, which is this one, congruent to TAI. It's the same 2 triangles. I just wrote them differently. They went TRI, TAI. The reason that they are congruent is by side, angle. This is why I shouldn't rush. Side. Okay, so here are my 3 pieces. They're congruent by side, angle, side. When we do this, hold on, we write where my sides are, which are in step 2 and 3, and where my angle is, which is in step 1. So this is corresponding to step 2 has a side, step 1 has a side, or step 1 has an angle, step 3 has a side. So side, angle, side, matching with side, angle, side here. Okay, so you'll see that notation when you look at copies of notes at the end of the week. That's what that is. Okay. Okay, thanks for powering through that. So tomorrow, no Zoom at 10, 9, at 9. Another thing you can work on tomorrow, so you know you have to submit 26. If you haven't grabbed it, there's a critical thinking task for last unit. You should come grab one. Okay, this needs to be handed in, so you wouldn't be able to give it to me till next Monday. But if you get it completed tomorrow, since you'll probably have extra time, I think some of you haven't grabbed it. I have too many copies for you all to have grabbed it. Have a good day.
Yeah.